Okay, for problem number 6, I don't think he's going to give you something too advanced in terms of Verilog, but nevertheless, you have to go through it. So the first thing you want to do whenever you make a Verilog module is declare a module, and then you can name it whatever. I'm going to name it test, and then declare your inputs and outputs. So if you want to imagine your module as a box, just inputs and outputs, you can see that our inputs are here and our outputs are here. And it doesn't matter the order you put in here. So we have inputs X, Y, and output G. And then don't forget your semicolons. And then inside the module, we declare which of these terms are inputs and which are our outputs. So since we have X and Y going in, X, Y are an input, and then same thing for our output. And then now we can do kind of circuit analysis. So you can see here, this first AND gate has inputs X and Y bar and output S. So we declare an AND gate, and the order does matter. It's output and then inputs. So output is S, and then our inputs are X and Y. X and not Y, pardon. And then for our second AND gate, our output is G, and our inputs are S and Y bar again. And then after that, we have to declare the end module. Not declare, we have to specify that that's the end of the module. Now that's one way to do it. Another way to do it is with the same module setup. Why is it down here? Whatever. With the same module setup, we can declare instead of putting this wiggly line in front of whatever variable to say that it's barred, we can have an inverter as its own gate. So to invert Y, we declare a NOT gate with an arbitrary value like R. R will be our output as our output, and then our input, which is Y. And then after that, business as usual, declare an AND gate for this one. And the output first, output is S, and then our inputs are X and R, because R and X are the inputs going in. And then for the final gate, S and R are the inputs, and then G is the output. So declare G first, and then S, and then R, and then you're done.